So today's lecture is going to be on integration, and last time in class we learned this. The integral of 1 over x dx is the ln of the absolute value of x plus a constant. Okay, and let's try our first example here. This is going to be the integral of square root of x plus 1 over root x squared dx. In order to integrate this, we have to FOIL. So we'll integrate this. When we FOIL it, we'll have square root of x times square root of x. That'll just be x. The cross term, which occurs twice, is square root of x times by 1 over root x. That will be 2. Okay. Then 1 over square root of x squared is 1 over x dx. Each of these terms we integrate individually. The antiderivative of x will be x squared over 2 plus 2x, and that last one is the ln of the absolute value of x, and then we add a constant of integration. So there we go. Voila, that's our antiderivative. Okay. Now this next one is a little bit more subtle. Suppose we're asked to integrate tangent of x. Well, we need to remember that tangent is sine of x over cosine of x. Okay. Then I'm going to substitute u as cosine of x. Du over dx is derivative cosine, which will be minus sine of x. And this is going to tell us that du over minus sine of x, that is dx. So this becomes sine of x over u, because u is cosine of x. Instead of having dx, that gets replaced with du over minus sine of x. So we're left with integrating minus the integral of, 1 over u du. That's negative ln of absolute value of u plus a constant. Then remember that u is cosine of x. So the antiderivative of tangent of x is minus ln of cosine of x plus a constant. Now here's our last example. Suppose you're asked to integrate ln of x over x dx. Now, there are two possible u substitutions here. You could take u to be ln of x, which is the correct substitution, or you could take u to be 1 over x. If you took u to be 1 over x, the derivative would be minus 1 over x squared, and that wouldn't be helpful. So instead, we'll take the substitution to be ln of x. In that case, du dx is the derivative ln of x, that's 1 over x. This says that x times du is dx. So this becomes u over x, but instead of dx, we replace it with x times du. Okay, and we're left with integrating u du, which is 1/2 times by u squared plus a constant. And now we have u squared, which is ln of x squared, and add a constant. So in this case, that is the antiderivative. In each instance, it gets a little bit more tricky, and there's several choices in which we could choose u to be. Those are often require a little bit of intuition or thinking about which substitution would be better. If worse comes to worse, you can try them both and see which one helps you solve the problem. Thank you very much.